we're back. So I also was talking about a few things, but I think I deleted that video. And it is mainly about the mindset and like the schedule that you need to have, that I need to have. And mostly, I want to make sure that I do at least one full exam like practice in the day, which makes me a professional in that regard. So I need to keep on doing that until I eventually master all these concepts. Okay, let's start with just the practice to show myself and also you how I would go about this. So, every page of this is filled with specific concepts. Some of them I have reviewed them a lot, but some I'm not good at it. I have not reviewed by any means. So, also, if there's anything that I don't know about, like I want to basically understand better, I would have Chat GPT by my side and make sure that I will get help from it to understand it better. And then there's also a lot of help that I will get from Jack Weston and try to understand, take the tests and practice questions from Jack Weston, and if there's anything I can get help from that from for each concept. And also I need to make sure that I am reviewing everything. So it might be even good to start with the Anki. So for the Psych Soc section, I have the Anki topics. For please disregard my language learning endeavors here. Just put it. Okay, I don't know how to make this a main deck by itself. Okay, it doesn't matter for now. We have also the mile down concepts here. What I'd like to do is first go over all the high yield concepts. Now there's the acid base that I have already studied. I need to also review them. There's the action potentials that I have studied. There's the amino acids, and this is from the IFD, which is a good channel by the guy and the girl who are brother and sister. They're down in the south, and I really like their channel, and it helped me have a good grasp on the MCAT, and yeah, so this is where I got it from. I believe IFD stands for Informing Future Doctors, and they helped a lot with this. And there's also the bioenergetics, the Gibbs free energy basically, and enthalpy, and entropy. There's also central dogma. Central dogma is about transcription, translation, the primase, all these enzymes involved in central dogma. What is a nucleotide? There is the conditioning, classic conditioning, operant conditioning, that is part of the psych-soc section. We have the enzyme kinetics. This is excuse my French, this is a bitch. It's not my favorite. I'm pretty sure a lot of people don't like this, especially the differences between these, the competitive, uncompetitive, and non-competitive inhibitors and their mechanisms, and the crazy questions that you can get from this. And it's actually kind of IQ based too, like challenges me. I like it. That's what I'm trying to say. Now, if you can see here, I have not what do you call it? I have not unlocked these concepts, so I would. This is the first time I'm actually coming across it here in the IFD. So that's the first one. There's the exons, introns. Exon is modified. It's the end product that you want to. They contain coding regions, and then there are the introns that contain non-protein coding regions. Non-protein coding regions, or is it like non-coding regions? I'll make sure what that is about. There's a transcription that leads to pre-mRNA, and post-modification involves addition of the 5' cap, the poly A tail, and splicing. PTM is the process that converts a pre-mRNA into a mature mRNA. And then we have glycolysis, which is basically how you metabolize carbohydrates. It is the first step of cellular respiration, the process of getting energy in the form of ATP. We all need to know these enzymes and steps and the yields of the process. There's also glucose, things that I need to know about the glucose: G6P, F6P, F16BP biphosphate, PEP turning into pyruvate. Glycolysis occurs in the cytosol. Glycolysis is the first step of cellular respiration for anaerobic or aerobic respiration. Now, when you are actually using your mind, you remember things, reminders, and I would love to write them on the desk. Mention 97 plus score. How do I pause this? I cannot pause here, so just bear with me. I'll edit that later. I'll cut that out later. Mention 97 plus score from. Glycolysis is the first step of cellular respiration for anaerobic or aerobic respiration. So it's both. And whatever the hell that is, I think it's yeah, this is good for memorization of this whole process. Then we have the hemoglobin oxygen dissociation curve. I believe, as far as I remember from 2 years ago, hemoglobin has a parabolic relationship with oxygen. So the more oxygen attaches to hemoglobin, it wants exponentially more oxygen, something like that. HB is available in two configurations, taut and relaxed, that correspond to whether or not they're bound to oxygen. The relaxed state is bound to oxygen, so high affinity for oxygen. The taut state is unbound to oxygen, so low affinity for oxygen. And we have positive cooperativity. It's when an enzyme binds a substrate. This event makes the enzyme have a higher affinity and thus more likely to bind more substrate. And it's like a kind of positive feedback. There's a negative cooperativity. It's when an enzyme binds a substrate. This event makes the enzyme have a lower affinity and thus less likely to bind more substrate. So cooperativity describes a protein's graduated response to substrate binding, meaning the addition or subtraction of a substrate can cause the affinity of a protein to that substrate to increase or decrease. So cooperativity is the graduated response of an enzyme to the addition of the substrate, to substrate binding. A substrate binds to an enzyme. proteins. So an enzyme is a protein, of course. Hemoglobin is a quaternary structure protein characteristically made of 2 alpha and 2 beta units. So as far as we know, a tertiary structure is a 3D protein, and the interaction between different subunits make a protein quaternary. And you may see the other units introduced in a passage that you do not have to memorize coming in. For example, fetal hemoglobin, HbF, is made of 2 alpha and 2 gamma units, while sickle cell anemia is a disease due to a lack of functional beta subunits, and thalassemias are diseases due to underproduction of units, leading to weird hemoglobin like HbH and HbBARTs. We're gonna explore that later. Now here's a funny thing. We need to make, here's a good thing. We need to have explore later, explore checklist, something like that. So we are going to have explore checklist. Let's make a checklist here. So if there is anything before what I want to talk about, so this was like a prep game. So I have a before and also a concept page, right? So a mind map, right? For now, I'm going to put that aside, and we're going to have a mind map, start a mind map here. Okay, mind, it's way too small. Okay, mind map. We can play with the sizes later. Okay, I'm gonna make a mind map later, but explore checklist. Need a checklist here. Do we have a checklist? So for example, the first time that I just read this information, just only a few seconds later, I can't strongly connect what was hemoglobin BARTs or thalassemia. Okay, now I'm trying harder and I can remember, a subunit is not functioning very well. That was what I understood. So in thalassemia or HbBARTs, HbH or HbBARTs, there is an underproduction of units leading to weird hemoglobins. Like, so there are weird HBs, hemoglobins, and HbH and HbBARTs are 2 examples. And when you take a step back, you see that thalassemias are diseases that are due to underproduction of units, leading to weird hemoglobins. So thalassemias are diseases due to underproduction of units. So when units are subunits of a quaternary structure protein like hemoglobin is so hemoglobin itself is a quaternary structure protein, and it is characteristically made of 2 alpha and 2 beta subunits. And you may see the other units introduced in the passage that you do not have to memorize coming in. Oh, okay. So in a passage, for example, you get a fetal hemoglobin, like HbF, which is made of 2 alpha and 2 gamma units instead of 2 beta units. So fetal hemoglobin is a bit different. It has a similarity to adult hemoglobin, where they both have 2 alpha subunits, but a fetal hemoglobin has a gamma subunit, 2 gamma subunits instead of 2 beta subunits. And while sickle cell anemia is a disease due to a lack of functional beta subunits in thalassemias, so if there is a lack of functional beta subunit, it results in sickle cell anemia. And thalassemias are due to underproduction of units, leading to weird hemoglobins like HbH or HbBarts. Now we have full understanding, which is amazing. So on our explore checklist, we will have HbH and HbBarts. What is thalassemia, and how does it affect a patient? Now, hemoglobin exhibits positive cooperativity. We know that. Each subunit of hemoglobin can bind one molecule of oxygen, and so 1 molecule of hemoglobin can bind 4 molecules of oxygen, because we have 4 hemoglobin subunits. Hemoglobin has 4 subunits, and its positive cooperativity characteristically makes a sigmoidal binding curve. So the binding curve shape is sigmoidal. The sigmoidal shape can be characterized by the S-shaped curve, or S-shaped, similar to S-shaped curve. Now, CADET, C-A-D-E-T, face right, describes the factors that if you increase them, you get a right shift, the Bohr effect. CADET, C stands for CO2, A stands for acid, D stands for 2,3-DPG, same thing as 2,3-BPG, whatever the fuck that is. E stands for exercise, and T stands for temperature. I have no clue what this is about, but I'm going to figure that out. Okay. Okay, break. Break.